Hello and welcome to another tutorial in Ansys Workbench. In this tutorial we're going to create a named selection using a worksheet. We will then create a remote point and then we'll use Ansys APDL commands to compute the rotations at that remote point. The geometry that we're going to use is this hollow square tube. So to begin with, I come over here to Model and I will right click and then click Insert Named Selection. I can see that it brings up this named selection in the project tree. I can see down here that it is looking for me to enter the selection, but I'm going to change the scoping method from geometry selection to worksheet. So I click on worksheet. It opens up this worksheet down here. To populate the worksheet, I come and I right click on the empty box below action and click add. That brings up this line for me to enter in the rest of my information. On entity type, I'm going to click on any entity type and I'm going to pick vertex because I will be selecting vertices to enter into this named selection. I then come to criterion and click on criterion, and the criterion that I'm going to use is the location along the z-axis. So I click location z. The operator that I'm going to pick is equal to. You can see that I could go not equal, less than, greater than, and so forth. I'm going to pick equal to. The units are in meters. Now in terms of the value, I need to be careful here that I enter in the right value. I can see my local coordinate system here is showing that z is going off in the positive direction this way. The length of my beam is a half a meter, so I actually need to enter in a minus 0.5 if I want to select these vertices out on this face here. So I come to value and I'll click in a 0 or a minus 0.5, enter. Now I come over here to generate, and I can see that it has selected 8 vertices, and I can see that the 8 vertices are shown over here so that I can double check to make sure that the right quantities were selected. So that's how you can do a named selection using a worksheet. In this example, it was not necessary to do that. I could have come here and selected these with a box select and other methods more quickly, but this shows you the power of using this worksheet if you had a more complicated. Before creating my remote point, I'm going to come here and change the name of the named selection that I just created. So I click on that and then click F2 on my keyboard and I'm going to type in points. I'm now ready to create my remote point. To do that, I come up to Model and right click, click Insert, and come down to Remote Point. And it generates this new line, Remote Points, in my project tree. I can come down here and see that it is waiting for me to enter in a selection. I'm going to change the scoping method from geometry selection to named selection and use the named selection that I just created. So I can click on that box and click on points. I'm now ready to enter in the APDL commands. So I right click on remote point, insert, and click commands. And this brings up this interface that lets me work with APDL commands. And what I need to type in here is measure underscore pilot equals underscore n pilot. And what I'm essentially doing here is I'm selecting these remote points to be the named selection points that I created. And so now I can go back through and make sure I've done everything correctly in my remote points. I can see that I've got my measure pilot equals underscore n pilot. Then I click on my remote point and everything looks good here, my name selection and my points. And then I can click on remote points here and it says show connection lines no. If I click this box and open it to click on yes, I can see that these lines are drawn connecting my vertices, and my remote point will be at the center of where all of those vertices connect. And so this is kind of a handy tool to make sure that you can see that your remote point is indeed where you expect it to be. You can also check the coordinates of your remote point by clicking on remote point and coming down here, and you can see that it's located at 0, 0, minus 0.5, which is right here at the center. So I'm now ready to continue on with the rest of my model development like we would do in a normal scenario. I'll click on Mesh. I've meshed this before, so I'll remesh it here, but I have changed my resolution to a 7 based on the previous meshing. So I'll click Generate, and this will generate my mesh. Now I'm going to come and enter in my boundary conditions. I'm going to enter in a fixed support on this end, so I'll be on the Face Select tool, click this face, and click Apply, and have a fixed support there. On this face out here, I'm going to put a moment. So I'll click on this front face, then click Moment. And the moment that I'm going to enter in is about the Z-axis. And so I can see that this is the Z-axis that I want to twist about. So I'll change this from vector to components and change my Z component to be 5,000 Newton meters. And you can see when you do that, you get a nice little red arrow showing that you've got an applied moment on that face. I'm now ready to select my output. I'm going to select an equivalent stress and then a total deformation. Then I'm going to look at the rotations at this point. So I'll right click on Solution, Insert, and this is where I will insert more APDL commands. So I come down to Commands and click on Commands. This brings up another APDL interface window, and here I type in my underscore rotation Z is equal to rotation Z, and now I type in the measure pilot that I had before, measure underscore pilot. And then I can multiply this by 57.29 to convert it to degrees. Otherwise, the result would be given in terms of radians. So I now have my APDL command entered, and I can come up here and click Solve. This is a relatively small model with not too many elements, and it'll solve quickly. I can see that I have green check marks by everything, and I can see that when I click on my commands, I come down here and I see that my rotation Z, so the rotation at that point is 0.26032. Now there's a bug that I want to warn you about. If I come here and come back to my rotation Z and I type a space and then a backspace there, I haven't changed the code at all. If I click on Solve and run it again, and then I click on my commands, I see that a 0 pops up. And what I have found is that if you make a change here, you've also got to come back to the command code underneath remote point and make a change. Even if you delete a space and put it back in, now that I have changed the code, it's exactly the same. I made a change and then changed it back. Now if I hit Solve, it'll go through and process the data again. And when I click on my commands, I get my 0.26 back. So if you make a change in your APDL commands here, you need to go back and make a change, and even if you change it right back, you need to do that here in the remote point commands APDL code. So hopefully this helps you use named selections in a worksheet and create remote points and look at rotations at those remote points. Thanks for watching.